Hello wonderful person, this is Anton, and today we're going to be talking about these really incredible discoveries coming from 4 separate white dwarfs that essentially suggest that the atmosphere of those white dwarfs is made out of what seems to be leftovers from various Earth-like and Mars-like planets that orbited in those star systems. In other words, it suggests that those white dwarfs most likely consumed their planets. But I really also wanted to have a reason to kind of show you this, the beautiful Helix Nebula. This is essentially the nebula that's one day going to become a white dwarf as well. Or actually, the star in the middle is going to become a white dwarf. Right now it's in the transition stage, and in the next few million years it's going to transform and become what's known as a white dwarf. Previously to this though, it was most likely a typical red giant star, and before that it was probably no different from our own sun. And because of all of this, it's actually a really exciting reason for us to talk about all of this, because it also suggests that maybe this is what's going to happen to our own sun one day as well. Now, this particular simulation shows you the size comparison between a typical white dwarf, which is comparable in size to our planet Earth, and of course our own sun. The white dwarf in this case being the famous Series B, the closest white dwarf to us. I also wanted to point out that you can check out this really beautiful 3D simulation created by this wonderful astrophysicist Salvatore Orlando from Italy, who makes these very realistic 3D models you can explore and that can actually teach you a little bit more about astrophysics as well. In this case, this is once again the Helix Nebula with the white dwarf or the future white dwarf right in the middle. Now, this isn't the first time we've discovered various leftovers around white dwarfs. Specifically leftovers from the disks and dust that can circulate around the white dwarf, or even planetary objects that used to exist here. In the past, several white dwarfs have already been identified where the disks do contain leftovers of planets, for example, but this is the first time where we officially know that the atmosphere of the white dwarfs themselves, or essentially that very thin layer on top of a white dwarf that's only possibly a few centimeters in width, is actually made out of what seems to be planetary leftovers, specifically crust in this case, crust from planets very similar to Earth and to Mars. But this particular discovery also allows us to kind of get a glimpse of what a lot of these ancient planets might have been like, because we literally get to see the composition of the crust of those planets, and a lot of these white dwarfs, or actually these 4 white dwarfs that were discovered with these leftovers, seem to be also really ancient. They're actually several billion years old, so by the time that the sun was only being born, these objects already had developed atmospheres and most likely were already consuming those planets. But how can scientists be certain what exactly is it that they discovered, and how can they be certain that it's actually crust? Well, all of this is of course chemical in nature, and in this particular case, by looking at these 4 white dwarfs out of about 1,000, they found out that the light coming from 4 of these objects was exhibiting specific spectroscopic wavelengths that can only be attributed to extremely specific atoms producing those specific observations. One of those atoms was lithium, and the other was potassium. All 4 objects had these 2 atoms. They've also identified calcium and sodium metals in there as well, and one of them even had potassium as well. Now, what's interesting is that the actual composition or the actual proportion of these metals were pretty much identical to what we usually find inside the crust of planet Earth, which is of course this extremely thin layer you see on top, the layer that we basically walk on. And this crust, at least by mass, doesn't actually represent much in terms of the planetary mass, but it is the layer that's more likely to be sort of absorbed by a star as it starts to tidally disrupt the planet. In other words, if we were to try to simulate this, by using Sirius B as well as planet Earth once again, you'll notice that as soon as the star starts acting on the planet, it's instantly going to start losing its crust first. And this is the material that's probably going to eventually get deposited onto the star first, with the remnants, especially the core and possibly even a large part of the mantle, possibly still orbiting in the region and maybe even becoming some sort of a disk that stays in orbit around the white dwarf for quite some time. But the crust, the outer layer, does get deposited first. And what's even more interesting is that something is definitely replenishing the amount of crust present in the atmosphere of these white dwarfs, suggesting that these planets are probably still in orbit somewhere, or at least their remnants are. And so this is definitely something that's still going on even today. And what these observations also suggest is that a lot of this dust and a lot of this crust material has been basically mixing with the upper atmosphere of white dwarfs for at least 2 million years. And although, as I mentioned in the past, mantle and even core material has already been found on white dwarfs, this is the first time that the actual crust from terrestrial planets was found as well. Especially because lithium and potassium are the elements that are generally found only in crust. They're not usually found in mantle or even in the core. They're also unlikely to be present in, for example, comets or even in gas giants, because these elements are generally only found in the crust of terrestrial planets. But I guess the other question is, how much of it was found here? Well, if we were to basically create a kind of a sphere out of all of this material, or somehow suck up all of this stuff from the upper atmosphere of this white dwarf, we would get an object that's actually not very large, only about 60 kilometers or so, or about 40 miles in diameter. And this represents about 300,000 gigatons of the material, but only a part of this is going to be, for example, lithium, only a part of this is going to be potassium, and so on. The majority of this is actually still rocky stuff, kind of similar to what we find in the asteroid belt, for example. Just to give you a better visual comparison, here's how this compares to the Great Pyramid of Giza in Egypt. So it is still a pretty large rock, it actually is a lot of material, but nevertheless it's not as much as, for example, well, our moon. As you can see, our moon in comparison is actually huge, so it's not a lot. And so in some sense this could have also been produced by some sort of a large asteroid, but once again this asteroid would have to have crust very similar to planet Earth. And so a much better explanation here is once again a chunk of the crust from a planet that probably orbited here, because scientists do believe that this is what happens over time when these white dwarfs reach a point in their evolution when they actually slowly start absorbing all of the material nearby as well. But the other interesting part here is of course the age of these objects. All four of them most likely were already white dwarfs about 10 billion years ago. So in other words, a lot of them were actually much more massive than our Sun, with one suggested to be at least 4.8 masses of the Sun. It was what's known as a B-type star. With others resembling stars like Vega that I've talked about very recently, because we might have discovered a planet here as well. And so these stars don't actually live that long, usually under 1 billion years, and so they transform into white dwarfs afterwards. But white dwarfs evolve really slowly and they cool down extremely slowly as well, and it will probably take trillions of years for them to reach this point when they're actually really dark and really cold. And so for the past 10 billion years, these white dwarfs were basically staying more or less the same. Although all four are already below 5000 degrees in temperature, meaning that they're not technically white anymore, they're actually same color as our Sun. At the same time, all four of them are basically remnants of some of the most ancient star systems with planets or planetary systems that we have in our galaxy. And so studying them and trying to identify more similar objects can actually help us understand how planets used to form even in the beginning of the universe billions and billions of years ago. Because remember, these planets that used to exist here probably existed approximately 10 to 12 billion years ago. And that means that they're some of the oldest terrestrial planets that we probably had in the galaxy. The other unusual discovery here is in regards to the mass of one of these white dwarfs. Now generally a lot of white dwarfs are not as massive and have much larger size. As they gain mass though, like for example this right here is representative of Sirius B, they start shrinking more and more. At some point, they can reach such a high mass that they become extremely small in size, but also very massive, about 1.4 masses of the Sun. And one of these white dwarfs is actually a lot more massive than other white dwarfs. And so any material present here is expected to disappear really quickly, mostly because this white dwarf is a lot more active and produces a lot more energy that has a tendency to break up any materials. But because it still contains those remnants of the crust, it suggests that it's actively being replenished in a very similar manner to what you see here in this illustration. Basically, the planet is probably still there and it's still being consumed as we speak. And that's of course billions and billions of years after the star has become a white dwarf. Which also of course means that these larger stars, specifically stars like B-type stars, can obviously also have terrestrial planets even though they only live for about less than a billion years. But whether these planets are common or not, only future will tell as the scientists investigate more of these white dwarfs. Remember, this was only 4 out of thousands of white dwarfs that we have in a database, so it's not really clear if this is actually a common appearance or if finding more remnants of these terrestrial planets is actually going to be a challenge, and if we just basically got lucky. Until further studies though, that's actually all we know. It's definitely cool to know that white dwarfs existed basically 10 to 12 billion years ago and already had terrestrial planets around them, and it's also interesting to know that some of them might have even survived the passage of the star into its white dwarf stage, but eventually they basically got too close to the star and started to be tidally disrupted and thus absorbed by the star itself. Now this is something we obviously expect our sun to do in the future as well, but at this point it's actually more interesting to find out how common these terrestrial planets were that early in the universe and what exactly was happening around them, and of course if any of them were similar to planet Earth. Planets with an atmosphere, planets with liquid water, and of course planets with potential biosphere as well. But that's not something we can find out just yet. Actually, for all we know, we might never find out. This is not something that we are currently capable of detecting or have any ways of knowing. Either way though, it's still an interesting search and it's still an interesting question. Did planets like Earth exist back then as well? But once we learn more, I'll make sure to follow this up in another video. Check out the study and all of the relevant links, including the media, in the description below. Subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by buying the Wonderful Person t-shirt or by joining the channel membership, all of which you can find in the description. I'll see you tomorrow, stay wonderful, and as always, bye bye.